Welcome back to the Organic Chemistry Reaction App Devlog. This devlog journals my efforts to make the Organic Chemistry Reaction App, OCRA. The app is currently available on itch.io and on Google Play if you'd like to check them out. And this entry in the devlog will cover the third and final part of my poster presentation at the Canadian Chemistry Conference. So in the last devlog, I said that reaction mechanisms are already a game. The primary gameplay mechanic of many popular cell phone games is just drawing lines on the screen. And reaction mechanisms are exactly that. There's no need to try to change the chemistry to spice things up and to make it fun. It's already a game. It's already fun. All we have to do is make that game. And so that's what I did. If you've watched my other devlogs, then you already know that this game is available. And anyone who views my poster will, at this point, be invited to try the game out. Here's just some pictures I'm putting on the poster that show that this is the game. There it is. Wow. And then after that, I want to just highlight 4 features of this app. The first thing is something that I've highlighted before. It's authenticity. This app is designed to give puzzles that are real chemistry reactions, chemical reactions, and they're drawn the way that real chemists would draw them, that is using skeletal formulas, and then the players are challenged to solve the puzzles the way that a chemist would solve them, using curved arrows. Presenting the chemistry in an authentic manner is important to me. It shows that even though it's a game, it's not only a game. It's also real chemistry. And anyone who uses the app should feel that while they're playing the game and just understand that this is beneficial to them while also being fun. Feature number 2 is accessibility. Finding practice problems is kind of a struggle, and it's not very fun because often it involves opening a textbook, and nobody wants to do that. But right now, you can access hundreds of puzzles on the app at the push of a button. I've got a picture here of a textbook and a phone, and this kind of proves the point. The textbook weighs 2.5 kilograms, while the phone only weighs about 150 grams. So it's just way easier to use. These pictures aren't on the poster, but they're just here for fun. Even beyond the weights of the textbook versus the phone, when you have a textbook, you still also need a pen and a paper and a surface to draw on so that you can answer the questions. Whereas with a phone, you don't need any of that. It's all on your device. And so you can do it at a bus stop. You can do it while you're sitting on the toilet. I don't know. And so it's just a much more accessible way to practice than a textbook is, or even going online to some website. Feature number 3 is efficiency. Finding practice problems often requires a large investment of time in non-practice activities. For example, you spend a lot of time actually even looking for problems to practice, either in a textbook or online. Looking for practice is not practicing. It's not an efficient use of practice time. In OCRA, puzzles are one click away, so you can get started fast and spend more time doing what you actually wanted to do, practicing. With a textbook, pen and paper, solving practice problems is slow because a lot of time is spent transcribing the problem onto paper. So you spend more time drawing the puzzle than drawing the arrows that are used to solve the puzzle. And again, that's not efficient. You want to be spending all of your time solving the problems, not setting things up. In OCRA, the puzzles are already drawn, it's already set up for you, and so it's ready to solve so you can get right to it. And finally, if you're practicing the old-fashioned way, it's hard to know if you got a question right or wrong. You get a question in a textbook, it says, what's the mechanism for this reaction? And you draw something. That doesn't help because you don't know if you got it right or wrong. And so if you're lucky, then the answer will be in the back of the textbook. But it probably isn't, because putting the answer in the back of the textbook prevents teachers from using that for like homework and assessing your knowledge, I guess, for grading you. So the answer isn't in the back of the textbook. Or if you're lucky and it is in the back of the textbook, it probably doesn't show every step. It probably just shows, what the starting material is, and then shows what the final product is, and it doesn't show any of the intermediate steps. So you still don't really know if you got it right or not. And so, of course, if you don't know what the answer is, then you have to go and you have to ask the internet for it, and somebody has to respond to you if you're lucky. And it's just really slow, so you don't know what you did right and what you did wrong. So how are you supposed to know what to focus on? It's hard. In OCRA, you're told if your answer is correct right away, so that you know what you don't know, so that you can focus on learning that stuff. And OCRA is just way more efficient than the usual practice methods available because it allows you to spend more time actually practicing, and it gives you that feedback right away so that you know what to practice further. And the last feature I want to talk about is that OCRA is informal. It's not homework, it's not a test, there's no grades, no marks, no stress. You play it for fun, whenever and wherever you want, with no worries about getting the wrong answer. Sure, technically other chemistry practice apps have the same benefits. Getting a 2 out of 10 on a quiz app isn't going to affect your grade in your class, but it doesn't really feel that way. Getting 2 out of 10 on a quiz app feels like you're on track to fail the test that you're studying for. And that feeling is not fun. These other apps feel like homework. They feel like studying. They feel like a formal part of the curriculum, even though technically it's just a side thing. That's not a big deal if you fail that quiz. It feels like you're going to fail the real quiz. I don't know. That's not fun. OCRA is not that. OCRA is fun, I think. And I'm going to sell it as fun anyway. I'm pretty sure I'm right. You can let me know, though. That's pretty much it for the poster, but like all academic outputs, you gotta sell the idea for the future so that you can get more investment. Sure, the current work is about some seemingly useless nanoparticle that's just like every other nanoparticle out there, but in the future, this nanoparticle is going to cure cancer. Something like that, right? I gotta sell it. So here it is. First of all, the app can get way better than it is right now. I can easily get to 10,000 plus puzzles. Easily. It might take a few years, but it can happen, and it probably will happen. Second, I can improve the matching of puzzle difficulty with user skill level. This would require some data collection. Right now, there's no good way of identifying how easy or hard a puzzle is. I'd need to collect data on puzzle success rates to figure that out, I think. But it's something that could be done. Third, I can add other puzzle modes, like featuring daily puzzles. People love doing daily puzzles. You can do puzzle rush modes, where you have to solve as many puzzles as possible in 5 minutes or whatever. Taking a lot of inspiration from chess again here. They have daily puzzles. They've got these puzzle rush features as well. So I could do things like that. Fourth, I can increase user control of puzzles by allowing them to filter for reaction types or functional groups. So say, for example, you wanted to practice puzzles involving amines, and you didn't want to focus on, puzzles with alcohols or ketones or thiols or whatever. You just wanted to focus on amines. You should be able to select a button there that just says, give me amine puzzles, and go from there. I can implement that. That could be done. Fifth, I can implement user analytics to help people identify their strengths and their weaknesses based on what types of puzzles they get right and which ones they get wrong. And that will then help them understand where they need to focus their efforts to improve their knowledge. Sixth, I can improve feedback for incorrect answers. Right now, the game does give you that feedback, but it only lets you know that you're wrong, right? If the error disappears and that red X shows up, you know you're wrong, which is good. But in the future, I could make it so that the game can explain the correct answer to you, so that you don't just know that you are wrong, but you also know why you are wrong, and why a different answer is actually the correct answer. And in doing so, you can actually learn a lot better, because you're learning as you solve instead of learning after you solve, I guess. And then finally, I can make better tutorial features. I just uploaded a brief tutorial video on YouTube, and the next release of this game will have a button that links to that video, so that technically the game is teaching people how to play it, which is a required feature. I've talked about the tutorial before. But this isn't really a good tutorial. It's a bare bones one that I made because it's a necessary feature. So it's there now. But I can make a better one. In-game interactive tutorials about how to play the game, but also that can expand to teach people about the properties of different functional groups and key concepts for various reaction types. That would be ideal. And I can make those. And all of these will take a lot of time. So these are lofty goals for sure. But so is curing cancer. So you kind of got to reach for the skies here. Just like everybody does with these academic outputs. Good times. And that's it. That's the poster. Maybe after the conference, I'll just do a video of the full poster so you can see it here too. There's nothing wrong with that, is there? Am I stealing content from the conference if I do that? Whatever. I don't care. Thanks for watching.